And on we go to chapter 9.2. We're going to now talk about multiplying polynomials. And I think it's important if we go through and just kind of look at the definition of polynomials again. That it's a sum of monomials or a monomial by itself. And each part is called a term. Okay, so again, this is a monomial, and here would be a binomial, right? Because it's got two parts, and then the trinomial. And these are all different variations of polynomials, okay? So let's go ahead and take a look at some multiplication here, okay? And here's one that's a monomial multiplied by a larger polynomial. So what we're going to do here is, as we move through and we have multiplying here, what we're going to do is we're going to take this piece and we're going to distribute, okay? We're going to multiply it by each piece all the way across, and we're going to end up with a large product. So let's do this. We have 2x cubed times x cubed. Well, if you remember your products of exponents, when you multiply two of these together, you're going to end up adding. So this is going to be 2x to the 6th plus, okay, and then I have 2x cubed times 3x squared. So it's going to be 6x to the 5th. And then 2 times negative 2 is going to give me negative 4. And I'm going to end up with x cubed times x, so that's x to the 4th. And then finally plus 10x to the 3rd power. Okay? And so this would be my final answer. Okay? I just distributed this across each of them. Okay, and if you notice, you can look in here and you can say, okay, this is there's a 2, another 2, another 2, another 2, right? If I were to reverse, if I started with this and reversed it, I could pull a 2x cubed out of it, right? Common factor across all of them. And that's a little insight into what you're going to end up doing with these a little bit later. So let's go ahead and take a look at another example. Okay, now this is pretty typical of what we're going to be looking at a lot of in the rest of this chapter. And what I have is I have two binomials, and I'm going to be multiplying them together. Okay, and you'll see there's kind of this gridded box here. And so one of the ways that people show this, and one way people like to sort of work with these, is they take each individual component from each binomial and they fill out this chart here. So what I'm going to do is I'm going to say, okay, x minus 4, we're going to say that's on the bottom here. So I have an x term, right, my term here, and negative 4, I put it here. And then I'm going to take each term from this side, 3x and 2. Okay, and then all I'm going to do is I'm just going to create a product of inside. So 3x times x is 3x squared, and 3x times negative 4 is negative 12x, and then 2 times x is 2x, and 2 times negative 4 is negative 8. Okay, and so then what I'm going to do is I'm going to go ahead and rewrite this. So I'm going to rewrite it as 3x squared minus 12x plus 2x minus 8. And then I'm going to combine my like terms, and really the only terms I have here that are alike are 12x, or negative 12x and 2x. So I'll end up with 3x squared minus 10x minus 8. Okay, and this would be your final answer. That's one way to do it. You can use the gridded box if you'd like. There's another way you can do it. This one is often known as FOIL, and you'll hear this, and what it means is first outside and then inside last. And I sort of use well, you'll see it. The way they like to do is they take the outside pieces and multiply them, and then multiply the inside pieces. And there's a specific technique for FOIL, but I just usually think of it as sort of a extra long. I look at it as an extra long sort of. Excuse me, I'm having a brain. Yes, I lost my train of thought. Okay, let's start this over. I use it sort of as a modified version here, and I don't necessarily use FOIL. I use it as sort of a modified distributive property. There we go. That's what I was trying to say. Okay, so let's go ahead and we'll take x. So what I'm going to do here is I'm going to take each of these pieces and multiply them both here. So I'm going to take an x and multiply it by both, and negative 4 and multiply both. So we'll take x, right? We'll do x times 3x, and so I've got 3x squared. Okay, and then I'm going to take negative 4 times 3x, so then I'm going to get negative 12x. And then I'm going to take negative 4 and multiply it by 3x. And so, oh no, I'm sorry, I already did that one. I'm going to take x and multiply it by 2, and I get 2x. Oops. 2x, and then I'm going to take negative 4 and multiply it by 2, so you get negative 8. And you'll see the result is the same as the previous one, right, when we did the gridded box. So we'll do a 3x squared minus 10x minus 8, okay? And it really doesn't matter in what order you do it, right? You could do x minus 4. In fact, we'll restart here. You could do, right, you could do it as x times 3x, and then x times 2, and then negative 4 here, and negative 4 times there, and this would give you 3x squared, and then x times 2, and so you plus 2x, and then negative 4 times 3x is negative 12x, and then you get negative 8. And you add it all up, and you get 3x squared minus 10x minus 8. And you end up with the same result. Okay? So, either way, it doesn't matter. And if you'd like the gridded box, you can do the gridded box. You can do the FOIL method. There's a couple other methods if neither one of these work that are in the book. There's like a there's one that's kind of like a multiplication, like a long multiplication way. But I'm not going to bother showing you that right now. Why don't you go ahead though and take a look at these two. Why don't you go ahead and try using one of the two techniques that I just showed you, and try to simplify or multiply out these polynomials and solve them. Okay, so why don't you go ahead and do that now. Okay, well hopefully you had a chance to do this, and hopefully you came up with 4b squared, right, because I'm going to do 4 times this, 4b there, and 4b times negative 2, so that's going to be negative 8b. And then negative b times, or negative 5 times b, negative 5b, and then negative 5 times negative 2, which is positive 10. And you're going to end up with 4b squared minus 13b plus 10. Okay. And on this other one, I'm just going to go ahead and I'm going to take each piece, and I'll take x squared and multiply. I'm just going to take each one and multiply it by both of them, right? So I'm going to get x cubed, right, plus 2x squared plus 2x squared. Right, 2x times x, 2x squared, and I did x squared times 2. So 2x squared plus 2x squared, and then 2x times 2 plus 4x, and then 1 times x plus x, and then 1 times 2 plus 2. So I'm going to end up with, sorry, I'm running out of space here, so I'm going to x cubed, and then 2x squared plus 2x squared is 4x squared, plus 4x plus x is plus 5x, and then plus 2. And there we go. My highest exponents are on the outside, on the left, and it goes down, and I have it all simplified. So why don't you go ahead and take these ideas, go ahead and practice. You can either do page 160 or 565, 15 to 31 odd, or you can do Khan Academy, and it's going to be called Multiplying Expressions 0.5. And if you feel real confident, you feel real good about that, you can go ahead and go into the Multiplying Expressions 1. It's going to be a little more difficult, but if you're feeling like a challenge and you want to get ahead a little bit and sort of get a little bit of understanding, then feel free to go ahead and do that. I would encourage it. All right, well, good luck.